In this video, we'll continue our discussion of section 11.5 with this example. It says, find the equation of the line of intersection of the following two planes. So now we're dealing with two planes that are intersecting. So let's take a look at our picture just to kind of get a grasp of what we need to do. So the line we are looking for is from here to here. All right, darken it up a little bit. Let me change my pen actually. So we're dealing with it from here to here. That line is what we're looking for. Now, to recall, we need two things to find for a line. So I'll write that out. Lines need a point and a directional vector. All right. First, let's deal with the vector. All right. So vector. And we're trying to find that line. And remember, for a directional vector, that's the actual direction that it's going in. So that black line there, if we take a look at it, we need the directional vector of that black line. Now, notice that I drew in the normal vectors. You see the red normal vector for P1 and the orange normal vector for P2. Those are our normal vectors for our intersecting planes. If you take a look at the line of intersection right there in the middle, this thing here is orthogonal to both of those. So if there's a way I can take a vector n1 and a vector n2, my normal vectors, and do something with them to find a vector that's going to be orthogonal to both, you should be saying that probably out loud already or thinking it. Well, to find that normal vector, or that directional vector, we are going to cross product our ends. And that will get us a directional vector. So we need to write out our ends here. So let's do, we'll do them color coordinated. I'll do that. N1, which is our red one. I grab that from P1, which is 6, -3, 1. N2, I said I'd color coordinate. N2, that is P2. And we grab those from the coefficients of those variables. So now we have everything we need to do our cross product. I'm going to write out the definition of this determinant, and then I'll give you the answer. If you would like, if you can't work it out on your own and get to the answer, let me know. I can show you the work. Just give me an email or something, or a text. So this works out. This is a cross product to save video time because I don't want these things to get too long. This ends up being -16, -31, 3. So there is my normal vector. That is, or directional vector. That is the vector going the line in the direction of the black line. So I have a vector. Now I need a point. That was my directional vector. So to do this, set x or y or z equal to 0 in system of planes. All right, so setting x equal to 0, we get -3y plus z equals 5. That's the top equation. The bottom equation becomes y plus 5z equals 5. And then we solve this system of equations. All right, just like in algebra. I'm going to multiply the bottom equation by 3. So this top equation stays the same. Sorry, I'm going to edge my iPod, or iPod. I haven't said that phrase in a long time. iPad. So I'm multiplying the bottom equation by 3. 3y plus 15z equals 15. And the reason we do that now is if I add down, the y's go away, and I get 16z equals 20, which means z is 5/4. Now I just go back to my equations, all right? So y plus, and I'm plugging in that z. 5/4 equals 5. If you work that out, you get y equals -5/4. I would encourage you to do that. Then we go back to one of our original equations. I'm going to use P2, and I'm going to plug all that in to find my, we have a z and we have a y. We actually don't need an x, or we have an x was 0. So we have a point. The point is 0, -5/4, and 5 over 4. So plugging these in into our, we're looking for a line, so it's not the directional vector and then one equation. It's going to be either parametric or symmetric. I'm going to go with parametric. It's typically my go-to. It's always this, and then the point, and it's mx plus b. That's how I think of it. Negative 16t. Y equals, the point is negative 5, 4, minus 31t. Remember, the directional vector is like a slope. Z is 5 over 4 plus 3t. This is a great answer. That would be the line of intersection of our two planes. Remember, a line can't be in 3D space, can't be represented with one equation. It's either parametric or symmetric. There we go.